We are going to do question 3 on our practice exam 1, which is a perfect rock, paper, scissors playing robot. So unlike humans, I'm basically developing this perfect rock, paper, scissors playing robot. So unlike humans, no bias whatsoever, perfectly random. So I played 10,000 games. So it's equal to 10,000 games. So 10,000 games, rock, paper, scissors. My robot threw rock this many times, paper this many times, and scissors this many times. Is the perfect a random rock, paper, scissors playing robot, or is this the perfect random rock, paper, scissors playing robot? That's a little tongue twister to say, at a 1% significance level. So what type of question is this? Well, we're trying to see we're going to do hypothesis testing. Are our frequencies the same or are they different? So this is going to be our kind of chi-square test. So whenever we're doing a chi-squared, we need our observed values and we need our expected values. And for chi-squared, remember we have nu equals k minus 1 minus r. R, is this question asking us if we are normally distributed, exponentially distributed, logarithmically distributed? No. So our r is equal to 0. There's no fitting parameters here. So we don't have to worry about r. K is our number of outcomes. So what are the number of outcomes or variables that we're comparing here? Well, we could either get rock, paper, or scissors. So we observed 3, 4, 3, 5 for rock, for paper, 3, 1, 3, 5, and then for scissors, 3, 4, 3, 0. What are our expected values? Well, it's just going to be n divided by 3, n divided by 3, n divided by 3. Because again, we expect them to be all equally probable. So in our hypothesis testing protocol, what do we need to do? So we know 1, H naught, so freak same, alternative, freak different, 3, what's our confidence interval? So 1% significance, so alpha equals 0.01, or we're at a 99% confidence interval. 4, we're going to have to calculate our chi-squared experimental. And then 5, we are going to go and figure out what is our chi-alpha nu. So we know that chi is 0.1, our nu is going to be equal to, what's our number of variables? K minus 1 minus r, this is 0. Number of variables are 3, so our nu is equal to 2. So we're looking at our chi 0.01 and then 2. So let's go ahead and pull up we could actually find that value right now. Let's go ahead and open our PowerPoint, lecture 4, right there, ready to go. And now we can look at our chi-squared tables. And then, so if I'm looking at 0.01, and then I'm looking at, again, we're never doing the alpha over 2 because chi-squared is basically right skewed. So we're going to look at 3 minus 1, so it's 9.201. So let's go and discard that. Let's go back to our notebook here. Equals 9 point, actually let me just make sure, 9.210. Because again, this is our alpha, and again, 3 outcomes minus 1, we're good to go. So what is our chi-squared? So for that, we need to do our observed, expected. So let's go ahead and kind of write this one out. So let's get this value right here. Actually, let's get this notebook ready to go. So I'm going to use my functions. Again, I've cleared my prior to opening this notebook, I actually cleared everything. So my observed is going to be equal to 3, 4, 3, 5, 3, 4, 3, 5, 3, 1, 3, 5, 3, 4, 3, 0. My expected is going to be just equal to 1/3, 1/3, 1/3 times my 10,000. So let's look at that numerically. So now my chi-squared is just going to be observed minus expected squared over expected, and then right here, 17.7. So I could go ahead and write that down. So 17.7, that's going to be my observed, actually my chi-squared experimental. So now if I go back into my PowerPoint, and let's go look at our right tail test, because we're always using right tail test for our chi-squared. So we found that let's go ahead and look at our right here. So we're doing a right tail test. So our kind of critical value was 9 point something. Our other value here was 17, so we are in the reject region. That is not the perfect and you can kind of look at that by those values, right? Like there's some pretty significant differences here. Let's just double check that oops, not that. Let's just double check that I have let's go back to our values here. These correct, but there's some pretty significant deviations from a perfect playing robot. So that's question 3 in a nutshell. So make sure, again, follow these processes, write out these steps, and then you'll be good to go in terms of your calculations. And again, accumulating these partial credit points. So we could even call this, experimental. But if you do each of these steps, I can see where you're going along the way. So if there's a math mistake, again, you kind of have all the correct values in here. And then if there's a math mistake, there's just a math mistake. So accumulate those partial credit points, and question 3 is done. Thanks. I'll see you in the next video.